How do analog and digital signals mix in amplifiers? Imagine you're at a concert where both live music and recorded tracks play together seamlessly. That's similar to how analog and digital signals work side by side in amplifiers. When you think about amplifiers, you might picture just boosting sound, but they do much more, especially when handling both types of signals. An analog signal is like a flowing river, changing smoothly over time. It's what you get from microphones, guitars, or sensors. Digital signals are more like a series of steps or snapshots, representing information in ones and zeros. These are used in computers, digital audio, and many modern electronics. In many systems, especially in audio and embedded electronics, both signals need to work together. To do this, the system uses special components called analog to digital converters. These devices turn the analog signals into digital data so they can be processed by digital signal processors. Think of it as translating a flowing river into a series of pictures. Once in digital form, the signals can be mixed, filtered, or adjusted within the digital domain. Digital signal processors can do things like change volume, add effects, or combine multiple signals into one. This is similar to editing a photo on your computer before printing it out. After all the digital processing, the signals are converted back to analog using digital to analog converters. This step turns the digital data into a smooth, continuous waveform again, ready to be amplified. The analog output then goes through the traditional analog amplifier stage, which boosts the signal to drive speakers or other devices. Some modern amplifiers are hybrid designs, combining digital and analog parts. For example, a digital mixer can combine several audio sources, then send the combined signal to an analog power amplifier. This setup is common in large sound systems or multi-zone audio setups. Designing these systems requires careful attention to noise, distortion, and latency. High-quality converters with fast sampling rates and plenty of bits ensure the signals stay clear. The analog parts of the amplifier must also be linear and low in distortion to keep the sound or signals accurate. This process is used in many practical applications. Think about a concert where microphones pick up voices and instruments, which are then digitized, mixed, and amplified for the audience. Or in a public address system where analog microphones and digital music sources are combined smoothly. Embedded systems also use this approach to process sensor data, convert it into digital signals, and then amplify it for monitoring or control. So, in essence, the mixing of analog and digital signals in amplifiers involves converting signals back and forth between the two forms. This allows us to enjoy the best of both worlds, the natural flow of analog and the flexibility of digital processing, all in one integrated system.